All right, looks like we've got lecture 922 and 923 today. Our objective, the student will convert degree measure into radians. So I want to talk about that real quick. What we have here is a XY coordinate plane and a circle that's got the center at the origin. And this angle we've got drawn right here is said to be the central angle of the circle. The vertex of the angle is at the origin, and we refer to the side that coincides with the x-axis. We refer to it as the initial side. Oh, my board doesn't seem to be responding. Let me see if it went into non-operational mode on me. Let me see if I can fix that. Let's see, that should work. Yay, all right. So this is said to be the initial side of our angle. And if we rotate so far and stop and make another side, this is said to be the terminal side of the angle. Right here. And if we're rotating, here's our initial side. If we rotate up this far and stop, this is our angle of rotation. In this case, it would be theta, or whatever we want to call it. I just called it theta. Alrighty. And we can rotate and stop here, or rotate even further. And we can rotate all the way around and stop so that the terminal side coincides with the initial side. And that would be an angle of 360 degrees if we went all the way around. Here, this angle looks like it's somewhere around 55, 60 degrees, just guessing. But what I want to talk about today is radians. We're going to get out of degree measurement and into radians. In Trig, you'll find that the radians are very, very helpful. And so I want to define a radian for you. A radian is an angle whose measure, if the vertex of the angle is at the center of a circle and the initial side is the positive x-axis, the angle who intersects an arc of the circle, such that if we were to measure the length of this arc, say cut it out and straighten it out, this arc would be the exact same length as this radius. If that's the case, this angle right here is said to be 1 radian. Okay. If this intercepted arc is straightened out and measured and it's the same length as this radius, that's an angle of 1 radian right here. Now, if we go 2 radians, we rotate another radian or so, be right about here. I'm doing all this by eyeball. Okay, so if this is 1 radian, this would be 2 radians, this rotation. This would be 3 radians. 3 radians is just almost, I'm going to get that a little bit closer to the x-axis, because it's almost 180 degrees. That's a little better. Okay. Here's 2 radians right here. Here's 3 radians. And if we go exactly pi radians, if we rotate pi radians, each radian is the angle whose measure is determined by the intercepting arc being the same length as the radius. If we go pi radians, that'll be exactly 180 degrees. There's pi radians, and we need to remember that. Pi radians is 180 degrees. Which stands to reason if pi radians, if we rotate pi radians and we wind up with an angle of 180 degrees, then it stands to reason that if we rotate pi and then rotate another pi, in other words, we rotate a full circle, then 2 pi radians is equal to 360 degrees. Okay? I wanted to introduce that concept real quick, and I also want to introduce positive and negative rotation, because we're going to be talking about that throughout the course of the year. I figure this is as good a time to introduce it as any. These rotations that we've been talking about, this initial rotation and every rotation thereafter, has been in a positive direction. If your initial side is at the positive x-axis, right here, and you rotate in this direction, this is said to be positive rotation. If we rotate in the other direction, here's our initial side right here. Here's our initial side. If we rotate in this direction and stop somewhere, this rotation is said to be in a negative direction. So we have negative rotation, negative angle, it could be in degrees or radians, and positive rotation, and the arrow indicates the direction of rotation. Okay, so there we go. What we're going to try to do today, now that we have an idea that pi radians is 180 degrees, 1 radian right here is so many degrees. I'll show you how to figure out how many. We're going to convert degree measure into radians to start. Okay, so here we go. Here's how we do it. Bearing in mind that pi radians is 180 degrees, 2 pi radians is 360 degrees, we're going to convert degree measures to radians, and we do that by multiplying our degree measure by pi over 180, that's just a fancy form of 1, and then we reduce. It's pretty simple. So here we go. I'm going to convert to radians. I have 390 degrees. I want to convert this to radians because I'm told to. So I'm going to multiply by pi over 180. Put a 1 under that, so I'm multiplying fractions. And now I can just start reducing. Well, I can see that both of these will divide by 10. 39 and 18 divide by 3. So I'm going to divide them both by 3. That will give me 1, 3 over 1 times pi. Dividing this by 3 is 6. And if we multiply, that won't reduce any further. 13 times pi is 13 pi. 1 times 6 is 6. So 390 degrees is equal to 13 pi over 6 radians. You'll see some people will just use radians. Often there is no symbol that we use for radians. We'll just say 13 pi over 6 and say radians. Okay, so there we go. Just multiply by pi over 180 and reduce the fraction. Hopefully I've reduced that correctly. Let me get my answer sheet and see how I did. Yay! All right. Negative 225. Here we go. We're going to do the same thing. Times pi over 180. And I'm going to see if this will divide by 3. You guys probably remember the trick for seeing if a number will divide by 3. If you add the digits of the number up and that sum is divisible by 3, then the number itself is divisible by 3. 5 plus 2 is 9. 9 is divisible by 3. So 225 is divisible by 3. So I will do that with my calculator because it's early and I don't want to mess up. 225 divided by 3 equals. That gives me 75. And dividing this by 3 is 60. I'm just dividing the top and bottom by the same number. I divided that by 3 and divided that by 3. I say, hey, these will both divide by 3 again. So I could have divided by 6. 7 plus 5 is 12. 12 will divide by 3. 60 will divide by 3. So I'm dividing by 3 again. 25 over 1 times pi over 20. I say, hey, both of these will divide by 5. So I'm going to do that. And that'll be negative 5 pi over, divided that by 5 and divided that by 5, over 4. 5 pi over 4, negative. And that negative, all that means is that if you're going to graph that, your initial side would be on the positive x-axis and you would rotate in this direction instead of this direction if I asked you to graph this angle of rotation. Negative is this direction, positive, we're rotating that direction. But for today, we're just converting to radians. All right, let's take a look at another one. 720 degrees. We're going to multiply by pi over 180 because it asked us to change it to radians. Put a 100, and so well, I can divide them both by 10. 72 pi over 1 times 18 is 18. I say, hey, I can divide both of those by 3. So that gives me 72 divided by 3. I'm going to do that with my calculator because my brain is numb at the moment. 72 divided by 3 equals 24 pi over divided by 3 is 6. And I say, hey, I can divide those by 3 again. So I'm going to do that. Well, actually, I can just say 24 divided by 6 and call that 2 pi. 24 pi over 6 is like 24 divided by 6, which is not 2, 4. 4 pi. There we go. I just reduced that. You could call it 4 pi over 1, but if you divide top and bottom of this by 6, or just go 24 divided by 6, you'll get 4. 4 pi. 4 pi radians. You can put rads next to it if you want to. Or just rad. Either one. Okay, negative 270. Let's see. All that means is we're rotating in a negative direction. What we're being asked to do is to change it to radians. So I'm going to multiply by pi over 180. I see that I can divide by 10 right off the bat. 27 pi. Oops. 27 times pi is 27 pi over 18. It'll be negative. And I can see that I can divide both of those by 9. So I'm going to do that. 27 divided by 9 is 3. 18 divided by 9 is 2. And that will stay negative. So negative 3 pi over 2 is negative 270 degrees. Let's check that, make sure that's right. Yep. And 720 is 4 pi. So yay. And this is radians. A lot of times you'll just see people leave off the rads. Oops. I kind of go back and forth. So there we go. We converted degrees to radians. Degrees to radians. The negative just means the direction of the rotation. We'll deal with that later. Right now we're just going from degrees to radians. You can do this.